So welcome to my YouTube channel. So today we solve the problem of max dot products with zero insertions, right? So this is the problem, and this problem related to the DP. Now how I explain it, right? So the problem is, firstly we understand the problem, right? Like given the two arrays A and B, positive integer size m and n, respectively, where m greater than is equal to n, correct, you are allowed to insert 0 anywhere into the second array B so that the length becomes equal to n. That's correct. Now the dot product of two arrays of equal length n is defined as a0 into b0 plus a1 into b1 plus an minus 1 into bn minus 1. Return the maximum possible dot product of the two arrays, right? A array is equal to, देखो A में क्या है, we have in array of A and B, and then we just have to find the output, and the output we have to find related to the our dot products, maximize the dot products, right? Now please understand. Now I just explain with the example. Like we have this one, right? We have this one. The length is n is equal to 5 and m is equal to 3, correct? Now we cannot change the order of element of B. We cannot change this order of element of B, right? We are only allowed to insert 0 anywhere, right? Now the original one we have only for this one, correct one. Original is equal to only for this one, and the possible is, what is possible? We have the possible is 0, 3, 0 and multiples possibles, right? 3, 0, 6, 0, 7, right? And then more possible ways like 0, 3, 0, 6, 7. That is also the possible ways. So our goal is to maximize the dot products. What is the dot product? So now the example of this one, if I take in, and then suppose our B is equal to like this, means 3, 6, 7, 0 and 0, like then dot products is, then dot products is, what happened, 2 into 3, then 3 into 6, then 1 into 7, then 7 into 0, then 8 into 0, right? And then answer is 31, right? So that is not good. Why? Because the answer is very, that means low. Can we do multiples? And if I can do another one, then we have the answer like this one, and we have like, we can do like this. Our B is this, right, where B is equal to this, and then our dot products is like this, right? Dot products, then this one, right? So this is the maximized answer, right? Now what we notice here, we are actually choosing which element of will be multiplied with B. 0 simply mean, right, skip the element of A. हम क्या कर रहे हैं, सबसे पहले skip कर रहे हैं एलिमेंट A को, एंड सबसे ज़्यादा क्या वैल्यू कर रहे हैं, B को. ऑर्डर ऑफ B कैन नॉट चेंजेस, राइट? B कैन नॉट बी चेंजेस, ठीक है, उस हिसाब से बना रहे हैं. तो इसमें जो है वो सिंपल सा ब्रूट फोर्स अप्रोच. व्हाट इज द ब्रूट फोर्स अप्रोच? व्हाट डू यू थिंक इन द ब्रूट फोर्स अप्रोच? तो सिंपल वन, generate every possible positions of the zeros, choose 3 positions among 5, and then for the larger n we just have to check. So in that time complexity is exponentials, that is not the feasible. Then what is the that means a better approach? So recursion, we can use a recursion, and in that recursion we just think like, right, in the recursion what we can do, f of I to j, and then maximize answer using, right, maximize answer using, right, using a of I and b of I j, like this. ठीक है. So at every positions we have two choice, skip, insert, skip and insert, right? So in that, what the formula we have to get here? So the formula we have to max of, that means there is the uh, max of a skip and take, right? And the formula of recursion very simple, like f of I to j, right, is equal to max of simple f of I plus 1 with j, and then a of I into b of j plus f of I plus 1, yes, and j plus 1, right, this one. So this is the formula we can get here, right? Only for this formula we can get here. So this type, got it? So in that there is also the problem is it will go in the order of 2 to the power n, right? So in that also we cannot get this. After that we can go on the DP and memorization approach. Also this will take a time. This part I will leave you with you, because if I use the recursion, then what we can do in memorization techniques, only use the DP of I and j, number of states n into m, each state computed once, right? Where in that it will compute the multiples of 10 at that means same index. But when I use the DP memorizations, in that that means not every time computed, only for once computed, right? So I just go on the optimal approaches, right, and then I will explain you the optimal approaches. So in that techniques we can use the mean approach, right? And the mean approach, we insert exactly 2 zeros into b. If we can get this one, so I know we have to insert 2 zero. That is the fix, that is the for sure. So instead of deciding where every element of b goes, we decide when to insert these two. Means in these approaches we think where we have to insert, and that means what is the every element and what the all things we have to add it here. But in optimal approaches we deciding where every element of b goes, right, where we have to insert 2 zeros. That is the right. So now I just explain you. I just write the code, and then you will explain it, and then you will get the something idea, and then you will definitely to understand the whole approaches, है ना, all the code explanation. So firstly comment it out. Now start from here. So int n is equal to a dot size, right, and int b is equal to b dot size, right. Now int k is equal to n minus m, and vector of int dp, and the dp of k plus 1 minus 1, initially all this minus 1. Now initially no element process and no zero inserted, right? initially no element processed and no zeros inserted, right? So here dp0 is equal to 0, right? Now for int I is equal to 0 and then I greater than or equal to n and I plus plus, simple one. Now just go on, now traverse backward, right? For int j is equal to k, j less than or equal to 0 and j minus minus. If dp of j is equal to minus 1 and then continue, right? Now option 1, insert 0, there is insert zeros, right? Now the inserting 0 is if j is not equal to k, then dp of j plus 1 is equal to max of dp of j plus 1 and dp of j, right? Here is option to match current ai with next unused element of b, right? Here is, that means match current, correct. Now if i minus j is m, then dp of j plus is equal to a of I into b of I minus j, right? Here now after this we just have to return the simple one, return dp of k, right? Simple thing. Now I'll start to compile it. There is any error? I think not. Yeah, b, what is error of declaring b? Okay, so the problem is n, and sorry, this is m not b, that is my problem. Now try to submit it. So hope it will submit it. So it will submit it. So in that, what you have to see here, and if asking about the time and space complexity, then what is the time and the space complexity here? So the time complexity is simple, order of n into what? N into what is our m minus n, that is m, we can take this n, and what is this? M into m minus 1, and this one. So that is the time complexity. In a wash there is the order of n square, but in a space that is only for this one, right? Order of m minus 1. So thank you for staying till the end. Please like and subscribe my channel. Thank you so much.